Super excited to have Marco here with me, the CIO of Goldman Sachs, a former VP at Amazon Web Services. Could not have someone better to talk about everything that's happening in generative AI. Literally announced, I think, in the Wall Street Journal today, their AI platform, so we have a lot to dig into. Yeah, so to start off with, tell us what is Goldman's AI platform strategy? You're partnering with what, Microsoft, Google, your former employer, Amazon. What was the strategy there?
I think what we realized early on in the AI journey is that in order for those models to really operate in an enterprise context, in a safe way, in a way that actually works well with the data that we have, in a way that actually is kind of ready for let's say, prime time, we needed to take a platform approach, meaning create a set of guardrails and create a set of integrations within the company and within the organization in order to get the best out of those models in the safest way. It's a little bit like the cloud. You cannot just go and take like open an account on AWS and then just start using it. You generally have to have a number of integrations around it. You need to have the ability to support multiple clouds. You need to have a lot of sort of a compliance work around it and so forth. And so with that experience, which we kind of call like not multi-cloud, but we call it poly-cloud, meaning that we try to get the best out of each cloud instead of the lowest common denominator. We kind of apply the same principle on the AI platform.
What are they best at from your observation?
Say again?
What are the foundation models best at, or any based on where you think they specialize?
Okay, and so first of all, I think the first design decision was we need to be able to support both like the large foundational models in the cloud, such as the Geminis and the GPTs of the world, and actually be able to use their latest and greatest because of the pace of evolution, but also be able on the same platform to host open source models that we might actually fine tune ourselves. And having that optionality, I think, is extremely important. Because, like you mentioned, I mean, behind your question is like, okay, not every model is created the same. And in fact, although there are many common model characteristics, but I think each model plays a very interesting trade-off between data accuracy or accuracy of the answers and actually capabilities to reason. And I think that's a key concept that we also internally try to leverage the best possible way, i.e., inside each model there is an ability to reason and actually process data and be able to find answers. And then there is a sort of a facts knowledge, almost like in every human. You read a book, and the book kind of leaves a shadow of itself into your brain. And at the same time, you learn how to reason on that subject, but also you need to you learn how to remember. And so those models have both of them together. And some are better at reasoning, clearly. Some are better at remembering the facts.
Who would you give your...
I think generally this larger kind of trillion parameter sort of a mixture of expert type of models that reach to that scale, definitely they're better at reasoning. The smaller models, when fine-tuned or when provided with a certain specialized segment, they tend to do extremely well on giving answers to facts. And so I think that's what we were able to achieve with the platform, is really like merging the two. And so often the platform allows you to take a complex question, such as let's say given this hypothesis on inflation, given this hypothesis on macroeconomics or on geopolitics, etc., get a sentiment on a specific metric, like, for example, I don't know, like oil or commodities or inflation itself. You have a complex question we send it first to one of the larger foundational models that breaks it.
One?
Either GPT-4 or Gemini. That's generally kind of the point of entry, okay? But we're also working with others like Anthropic and others, which Claude is actually a pretty extraordinary model. And they have the ability to really get the essence of that question and break it into tasks. And then we operate, we have a LangChain type of based, or like sort of a chain of thought type of agent model that goes and retrieves data from either external sources or internal sources or vector databases or models, specialized models themselves. And then all that comes back to the larger reasoning model, and then that gets summarized into an answer. So this is orchestration between models that is done very effectively, but it requires a platform. It requires a platform that is able to kind of create these workflows and actually do it in
Among that, does
safe
Goldman
way.
have its own proprietary model?
We made a decision early on. I have to say that initially we were kind of tempted to do that.
You're like, I know how to do this. I could do
Yeah, initially, like maybe a year and a half ago, everybody was like, oh my God, I need the GS model. How can you not have it? And
Bloomberg came up with it, didn't they?
They definitely did that. We had conversations with that. But then you realize, it's like a little bit like this. There is a lot of, if you start from scratch, there is a lot of general knowledge that is kind of common to everybody that you don't really need to spend time or money on. It would be like saying, hey, I want to hire a new employee. I'm going to hire them when they're 5 years old so that I can actually teach them everything.
Right.
Well, maybe. That would be a real GS person. But I don't know how scalable that would be. Whereas you can get them maybe out of college, where they got a lot of the basic knowledge. And that's really what we do. You take like an open source model that has learned English, has learned some reasoning, some math, and whatever. And then from there, with data, you're kind of then making them into not only the PhD, but you make them into the experienced employee. And so the GS model, if there is one, is really the combination of a model that exists and
Llama?
our data. Like, take a Llama, for example, and I want to teach it how to write software in our own proprietary language called Slang. Well, then I can take the coding capability that it already has and then, add that.
Did you do that? Do you have a
knowledge.
Llama model trained on Slang?
We have a Llama model that is actually already pretty good at spitting out Slang. And surprisingly, I have to say, this is actually really like sort of something that we look at and experiment with every day. It's still an open debate whether we really need to fine-tune the weights of the model or we just need to present the right examples to the model. And I tell you that our scientists are seeing, it's still an open question. It's like, like if I want an answer, if I want an answer for you, you're an experienced programmer, do I need to really kind of modify your brain in order for you to be able to program, or do I just give you a lot of reference books or reference code? So it's really a combination of both. We've been obviously doing some, weight kind of type of work with, adapters model, LoRa, LoRa adaptation, trying to kind of, add a little bit of tuning to the weights. But I think the way you present examples, it's really the extraordinary part. And so, the few shots examples, the vectorized examples, finding, and so we really
using like the context window, basically.
We definitely use the context window, but we use it in a way that, the platform itself, by the way, has the ability to standardize the retrieval augmented generation process, and actually, I don't know if I said that before, so my PR people are going to actually not be happy with, but we actually played with our own embeddings. For those of you who know what I'm talking about. So the embeddings is really like the way we explain things to the AI in a vectorized way. And those techniques that are all around the model, i.e. the way you extract data, the way you chunk data, the way you embed, you create the embeddings, the way you feed it to the model, is really the secret sauce. And I think that part is where we get where we see the maximum, in a way, improvements of the output.
What does this mean for foundation model companies? I don't know. If I'm at Microsoft, I would prefer you say, oh, they're the smartest. We work with them. It's a deep relationship. And you're saying, oh, no, we take a little bit from everybody. Like, as somebody who is in the hyperscaler world, what is it? What's your read on the foundation model business, given your own experience?
Well, I think there's if you interview a lot of people, you're going to have the open source maximalists that are going to tell you oh, for enterprises, all open source because that's the only way you can actually kind of feed your own super proprietary data. I'm actually more like towards no. There is plenty of space for the large foundational models like Microsoft or like Google, because make no mistake, their reasoning capabilities are actually superior. There is no question. And so I'm actually we're very, very close. And I think one of the key elements of this platform strategy is the fact that we were able to partner really, really deeply with those companies. And at this point, the same way as we use AWS for something and we use Google Cloud for something and we use Microsoft Azure for something else, we are very happy to work with all of them because it's very early still. You know what I'm saying? Like, things are not at all commoditized.
Do you think models are going to get much smarter in the next 12 months?
I think there's going to be a big jump in reasoning capabilities, especially in reasoning capability, especially in the ability to do, and I fully buy into this vision of actually going from the 5-second task to the 5 minutes task to the potentially 5 days task, meaning those models are going to be able to do stuff that takes time, that requires multiple iteration. Like, for example, take a coding example, which, by the way, is one thing that is probably the biggest thing that we deployed so far. Is like almost all our developers as of today, as of this month, all our, like Java, et cetera, developers are all enabled with Copilot technology.
Microsoft Copilot?
It's Microsoft Copilot, but I have to say that, for Slang, for other specialized languages, we're also using others, like I told you. But today, those are like quick tasks. Remember, the autocomplete task was a few second task. You start typing, and then you complete the line. Now you have the chat task, which is, okay, give me like a way to call, this API, and then you get like the 5 minutes task. I think very soon we will see, okay, I have this code base that I need to migrate from React to Angular, or from Angular to React, or you want to migrate from, Sybase to Oracle, or from Oracle to DynamoDB or Aurora. You could actually ask that, and then even a week later, the AI could go back and say, hey, I migrated 98% of your code, and here are the snippets that I need you to check. That stuff, I think, is in line of sight. And it's the same for document management, it's the same for content creation, and I think those long-running agents type of tasks, in my opinion, without, without knowing anything particularly proprietary here, but you can really see that. I think it would be probably the biggest evolution.
It's clearly impactful on the coding side of the house, and you see a lot of opportunity there. I mean, I think people, here at Goldman, they're like, are you making trades with AI yet? Or how much can you just sort of, are you making a bunch of money by, having an LLM go at it and spit out what you should do? And
first of all, I tell you that we're hoping that, first of all, that we're going to save a ton of money. And I tell you that is really the first wave. The first wave, the first wave, and I see what, I heard you. I'll answer that. I heard you. So, if you take developers, we have about, over 12,000 developers. And we see easily 20% efficiency gain, which, if you consider how much time developers spend coding, maybe say 50%, it translates in 10%, which could be 1,200 developers for free, so to speak. Now, always people asking me, okay, then you're going to live with 1,200 less developers. Well, the stuff that is below the line today that we want to do, that it's going to make money for us, it's very long. And so it's more about you do more with less, or you do more with the same. In fact,
which?
Well, I think honestly, I've been in IT for 40 years or so, like regrettably, and I've never seen IT spend go down ever, ever.
Yeah.
This time, I think, if anything, it will probably flatten the curve of growth a little bit in terms of spend. You might be able to spend the same, but it's more about reinvesting that. That's kind of what I'm anticipating. But I tell you that that in itself is cost saving, obviously, because if you are supposed to spend 1.1 times and you spend 1.05 times, it's actually a really big saving.
Yeah.
And secondly, is not only developers. I mean, there's a lot of manual work that is done in every company, in every bank, which is, like a lot of toil that this could eliminate from the system. You take a document that is 200 pages long, that is not really structured properly, and you need to put it into a template for a certain committee to approve a certain decision. I mean, AIs already today, they can do that sometimes better than humans. And of course, you have the human in the loop to check it. But imagine like meetings. I think last year we had something like 1 million meetings. It's, I don't have the precise number, but that's the order of magnitude. Imagine how many of them require a briefing being created, and imagine, a briefing takes 2 hours, and now you have 2 million hours that could be, saved by an AI actually doing a perfect briefing. I'm here today, what should I be, what is top of mind? Or I'm interviewing Mark Argenti, what are the things that he said? And all that is absolutely in line of sight. Now, back to your original question on trading, okay? Because I don't want to avoid that. So think about this. There are two big areas. There is the area of efficiency and productivity, which is kind of your wave one, where you have developer productivity, you have call center productivity, you have knowledge worker productivity, etc. And then there is the sort of the wave two or so, where you have potentially alpha generating type of AI, okay? And so when you talk about trading, trading is a big word. It's like saying, banking. So there are different types of trading. And so if you take, for example, let's divide into two big classes. One is you need to predict the movement on the market in the next, say, second. That's one class of problem. And the other one, you kind of need to make long-term predictions. For example, I don't know, the option price of a commodity in, even like 5 years or 1 year and so forth. Those are two completely different problem sets. In the first one, we've been working on with ML for years to kind of, try to get those trajectories in a way. And we started with, like regression models, logistic regression, and then you start with random forest, XGBoost, and then you go into recurring neural networks. So you have this progression of techniques. And today, LLMs are kind of the next generation of that, which...
But not there yet. That is the answer.
Today, the best LLM kind of is on par with the best traditional model. So it doesn't really give you more alpha yet. But there is a lot of active research, and there is a lot of hope, quote unquote, that something that is kind of a perfectly optimized, which is the older type of approaches, if it is on par with the stuff that is not yet optimized, so maybe there is something, a lot to hope for. And so that part is an active area of research. We don't have any data today that will confirm that they will do better. But given the rate of evolution, let's say that some very smart people could say that that could be a definite possibility. And then the second part, when you do more long-term prediction, I think there is a lot that these LLMs can do in really processing unprecedented levels of data, and then getting into, for example, testing your hypothesis. And that's really where they can help you a lot, because to test a hypothesis, today it could take weeks, because you need to go through back testing, you need to find similar market conditions, etc. And imagine maybe you can do 5 per month or 10 per month. Imagine if you could do 1,000 per month. And so this ability to test your hypothesis and discard the hypothesis very quickly, which LLMs can help you a lot to do. I think that can actually eventually help you make better, long-term, long-range decisions. So that's a little bit of a long answer, but that's kind of the direction. And the cool thing is that this platform that we build allows us to do those applications on top of the LLM in a fraction of the time that you would do if you built from scratch. And that's kind of, I think, this kind of flywheel effect that we really like.
Well, we could talk all day. Thank you so much for coming. Lots of room to run. Marco Argenti.
Thank you so much, Eric. Thank you.